This is page 96 of the IB of the Incredibles book. All right. Let's look at this. So 23, find the values of a and b that make the function differentiable. For a function to be differentiable, not only does it have to be differentiable, it must be continuous. All right. So two things must happen. That these two have the same value at the boundary or the same limit. The easiest way to say that they have the same limit is just plug 1 into both pieces. All right, so we're going to plug 1 into the top one. So it's 1 cubed, or just 1. And plug 1 into the bottom one. That would be a times 1 minus 2 squared plus b. I understand that there is no equality here, but when you take the limit as x approaches 1 from the left, it's the same thing as plugging in 1. Okay, so that's why we're plugging in 1. So it's irrelevant that there's no equal to bar here. We're thinking of it as taking the limit, and remember, limit doesn't matter, doesn't care whether there's an equal or not. All right, so this becomes 1 minus 2 is negative 1. Negative 1 to the second power is positive 1. So this ends up being a plus b. So that means a plus b must equal 1 for this to be continuous. Right? They have to have the same limit on both sides for this function to be continuous. Now, to be differentiable, let's take the derivative. So I'm going to take the derivative of this function. And I'm going to run out of space. All right. So take the derivative, and just take the derivative separately. And here, at this point, you don't really know the rules, but we're going to cheat. So we're going to just use regular power rule. And there is another rule lurking in the background, but it's not necessary for this one. So we're just going to ignore it. And b is a constant, so when I take the derivative of b, it's 0, so it goes away. And this is x less than 1. Technically, we could have multiplied this out, the x minus 2 squared, and we would have gotten the same derivative. I just cheated. But okay, you'll get over it. All right, so at this point, we're going to plug in 1 into both of those, so you get 3, right? 3 times 1 squared is 3, and we plug 1 into that, turns into a negative 1, so it's negative 2a. So we get a equals negative 3 halves, right? I'm solving this for a, divide by negative 2, and I get negative 3 halves. Take this and plug it into the a plus b equals 1. And so I get negative 3 halves plus b equals 1. So b equals 5 halves. So those are our two values. A equals negative 3 halves and a equals 5 halves. Okay? All right, let's do b. Same idea. We're going to plug in the 2, and hopefully I do it more organized fashion. All right, so plug in the 2, and I get 4a plus 10. And plug in the 2 there. 4 minus 12. 4 minus 12 is negative 8 plus b. So it's got to be equal to negative 8 plus b. Let me double check my math here. Yeah, all right. Now let's take the derivative. Let me take the derivative over here. F prime of x equals, so that'll be 2ax. The derivative of 10 is 0, so just 2ax. And this is 2x minus 6. Derivative of b is 0. All right. So we plug in 2 into these. So that's going to be 2 times 2 is 4. So it's 4a on the left. And plug 2 into that, and you get 4 minus 6 is negative 2. So I got a equals negative 1 half, right? I'm dividing by 4. Negative 2 divided by 4 reduces to negative 1 half. Now plug negative 1 half into the other one. So it'll be 4 times negative 1 half plus 10 equals negative 8 plus b. So that's negative 2. So that's 8 equals negative 8 plus b. So I get b equals 16. And that's it. Those are the two values. Going on to C, doing it again. Let's rewrite this as a x to the negative 1, so it's easier to take a derivative. All right, so again, plug it into 1. So I'll plug it into the normal form. A over 1 is just a. Plug 1 into there, and I get 12 minus b. So remember, they have to be equal to each other for it to be continuous. and then take the derivative. That's going to be, so power rule, negative a x to the negative 2 and negative 2bx, negative 2bx. Okay. Plug in the ones again. So plug 1 in there, so it's negative a. Plug 1 in there, you get negative 2b. Okay, so let's clean this up a little bit. So that's a equals 2b. Since both, so a is equal to 12 minus b and a is equal to 2b, we just set them equal to each other. So 12 minus b equals 2b. So we get 12 equals 3b, b equals 4. Take that value, plug it into either one of these, right? 12 minus 4 is 8, or 2 times 4 is 8. So we get a equals 8. There's our two answers. Going on to D. Plugging in 2 into both of them again. All right, so that's 8a plus 1. And plug 2 into that, and I get negative 1 squared, which is positive 1, so it's just b plus 10. All right, now we take the derivative. So that's 3ax squared plus 1 goes away. 2bx minus 3. The plus 10 goes away. Plug in the 2. So that's going to be 4, right? 2 squared is 4. 4 times 3 is 12. 12a. Plug 2 into that expression. 2 minus 3 is negative 1, so it's negative 2b. I guess we should probably clean this up some. All right, so I'm going to solve this one for b. So that'll be negative 6a equals b. Let's go ahead and just plug that into here. So that'll be 8a plus 1 equals negative 6a plus 10. All right, so I just replaced the b with negative 6a. So bring the 6a over and bring the 1 over. So that's going to be 14a equals 9. So a equals 9/14. All right. Then to find the b, we're going to plug the 9/14 into there. So it's negative 6 times 9/14 equals b. So that's what? Negative 27 over 2 over 7. All right. If I made an error, please leave a comment please drop a comment, say I made an error. I don't feel like double checking that. Okay, good luck with that. All right. Let's just take the derivative for these. All right, so that's theta. These are not zeros, these are thetas. We're taking the derivative, f prime of theta, right? Pi over 2 is just the constant, so we're going to multiply pi over 2 times the derivative sign. Derivative sign is cosine, so it's pi over 2 cosine theta. All right, and minus the derivative of cosine is negative sign, so it's a negative sign. So don't leave it like this. Don't leave it minus negative sign there. So we'll make it pi over 2 cosine theta plus sine theta. And that is adequate as an answer. All right, number 2. Derivative of x squared is normal power rule, so it's 2x. Derivative of cosine is negative sign, so we're going to change that minus to a plus. That half is coming for the ride. Nothing happens to it. And there's that. Okay. Excuse me, I'm about to cough. The coffee was fended off with a glass of water. All right. Or maybe not. Okay, it wasn't. All right. Number 3. We learned that the derivative of e to the x is itself, so that doesn't change. Derivative sign is cosine, so it's just cosine. That's it. Number 4, remember we don't have a power rule for in the denominator, so we're going to rewrite that first. So it's x to the negative 2 minus 2e to the x. So when we take the derivative, we could use regular power rule on that. So it's negative 2x to the negative 3. Right, bring down the exponent, subtract 1 from the exponent. Negative 2 minus 1 is negative 3. This part doesn't change. Okay, that's it.